Now, question 2 says that we are given this quadratic pattern of 12, 21, and 34. So the first question says that we must write down the next two terms that follow. So we're having our quadratic pattern of 12, 21, and 34, and we want the next two terms. Right, so what we're going to do is we're going to find the difference of these two terms. So 21 minus 12 is going to give you 9, and 34 minus 21 will give you 13. So we know very well that the second difference of our quadratic number pattern is constant, which if you minus 13 and 9 is going to give you 4. So we know very well that it's just going to remain constant. So the next term, if you want to identify here, we know it's going to increase by this 4 here. So it's going to be 17, because 13 plus 4 is 17. Then 17 plus 4 is going to give you 21. So now to find the next term, which is this one here, we're going to say 34 plus 17, it should give you 51. And 51 plus 21 should give you the following term, which is 72. So these are the next two terms of the sequence. Now 2.1.2, we are asked to determine the formulae of the nth term of the number pattern. So remember that we are having our quadratic sequence written like this, and we found two terms, so 51 and 72. The difference between these terms here, it's 9, 13, 17, and 21. So we know that the second difference is constant, which is 4. So to find our formula, we're going to say this is equal to 2a. So 2a is equal to 4. Divide by 2 both sides. We're going to have a being equal to 2. And then to find our b, is going to say 3a plus b is equal to the first term of your first difference, which is equal to 9. And we know our a is equal to 2 plus b is equal to 9. Then our b should be equal to 3 if we transpose the 6 to the other side. It's going to be 9 minus 6. Then a plus b plus c is equal to the first term of the quadratic pattern, which is 12. And our a, we know it's 2, plus our b is 3, plus c is equal to 12. We add the 2 and the 3 is going to give you 5. We transpose to the other side, so you should get c being equal to 7. So now you have our a, b, and c values. So our nth term, we know the standard formula is equal to a n squared plus b n plus c. So we're going to substitute the values. So our a is 2, so it's going to be 2n squared. Our b is 3, so it's going to be plus 3n. Our c is 7 plus 7. So this would be our nth term. So now 2.1.3 says that calculate the value of the 60th term of the pattern. So the 60th term of the pattern, so we're going to use the previous nth term that we calculated. So we know very well that our general term of the quadratic number pattern is equal to t. N is equal to 2n squared plus 3n plus 7. And we want t of 60. Right? So which means where there's n, we're going to substitute 60. So it's going to be 2 into 60 squared plus 3 into 60 plus 7. So you use the calculator, the solution you should find is 7,387. 2.2. Consider the following finite arithmetic series. So when they say finite, which means that it has an end point. Infinite means it is continuous. So this one, it has an end point, which is 172, which is the last term. So 2.1 or 2.2.1 rather says that calculate how many terms are in the series. So if you look, we are told that this is an arithmetic series. So we're going to use the standard formula, or the standard, or the general term rather, of an arithmetic sequence. So in this sequence, we know the difference is constant since we are told that it's an arithmetic sequence. The first term of this sequence, our a, is equals to 4, and the difference is 7 minus 4 will give you 3, and 10 minus 7 will give you 3. So we know our d is equals to 3. So we're going to use Tn is equals to a plus into n minus 1 multiplied by d. So this is the formula that we're going to use to find the value of n. So our general formula for an arithmetic sequence is Tn is equals to a plus n minus 1 d. And we are given Tn, which was the last term, it's 172, and the first term is equals to 4 plus into n minus 1, and our difference is 3, difference of the sequence. Then we transpose the 4 to the other side. We're going to have 172 is equals to, then the 3 will multiply every value that it finds inside. So we're going to have 3n minus 3. We know here it's supposed to be minus 4, right? And then we transpose the 3 to the other side. We're going to have 3n is equals to minus 4 plus 172 plus 3. Then we divide by 3, we divide by 3 everything. So n should be 57. 2.2.2, determine the sum of the series. So you already know a being equals to 4. You know the difference is equals to 3, and you know the n value is equals to 57. So you're going to use the formula of the sum of an arithmetic series, which is n over 2 into a plus l. So the reason why you're using this one is because you already have the last term. So you can also use the other one, which is Sn is equals to n over 2 into 2a plus into n minus 1 multiplied by d. You can also use this one here. So using our sum formula, which is n over 2 into a plus l, and you know it's sum of 57 terms. So 57 over 2 into our first term being 4, our last term being 172. So the solution here is supposed to be 5016. So that is your sum. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.